now?
So we're Friday Innovations. My name's Derek.
Mason.
Jared.
Luis.
And we're presenting our product, the Juice and Go phone charger. Jared.
All right, so we started out, when we decided on this project, we were looking at kind of the background story is several among us like to do backpacking stuff and outdoorsy sort of stuff where for extended periods of time you may not be able to have access to like a wall outlet or something like that to charge your phone. So we thought it would be convenient to have a disposable power source or where you could just swap in, replaceable batteries. And we came along with, after some research, we decided we could fill this need with 2 AA batteries through a couple of, actually I won't get into too much because that's all his area, but anyway, we looked in the market. We did find one product on the market that had the same sort of idea behind it, but it was for quite a bit more than what we were planning on hoping to come in for our price.
It was $20 compared to.
Yeah, well, our price that we nailed down is about $12. So, but we went with. That's really what motivated, just kind of the convenience of a disposable power source, and as far as there were some other ones on the market that were about the same price, but they were not disposable. As far as rechargeable to charge your phone. That's pretty much it. Well, we did go over some battery issues. We had several different ideas initially as far as what sort of a source to use, and some of them knocked themselves out of the picture. Other ones we ended up deciding on through our matrix, design matrix. Someone else going to go over that? Okay, well, our design matrix, I believe we've got it in here. Yes. This is our design matrix. We had the different power sources that we threw around were AA, 2 AA's, 2 AAA's, and then a lithium ion that we got out of a drill from, just your Lowe's. And it seems like there was one more.
You can zoom out.
Just rechargeable. Well, no, those were the main 3. We can always substitute in rechargeable. So we ended up with. It was kind of close between the AA and AAA. Like I said, one of them narrowed themselves out. This actually did it to itself. This is a drill out of the battery, rechargeable. It wasn't disposable either, but it looked promising as far as being able to hold a lot of charge. But Mason all of a sudden noticed his backpack was smoking, so that wasn't a viable option. The really came down to with the AA, we got more charge for the weight and size savings of the AAA. Really didn't, because of the other devices we had to do to get the voltage correct. It didn't make sense. It really did save us any size to go with AAA, so we got extra charge with the same size device.
Okay, and I'm going to talk about the issues we had in our project. We hit roadblocks every step of the way. When we started, we were mainly coming up with the AA's or the lithium-ion design. I was really excited about the lithium-ion design, rechargeable, and we were expecting to have many recharges off of a single charge of this battery. Until one day, getting ready for school, I grabbed my backpack and a massive plume of white smoke came out, and that was very alarming. Had to take it out, and it was smoking and a horrible smell, and it was just nasty. Let that sit for quite some time, but that threw itself out of the picture. So then we just decided to stick with our AA design. This was our first board that we were going to attempt to get the voltage correct, because USB requires about 5 volts, and 2 AA's in series gives you 3 volts. That's not going to charge a phone at all, not even close. So this board boosts it up to about 5 volts. When I first tried this board, I had to drop it the first time because the board got so hot. that was kind of concerning. And on the second try, it burnt itself out. So that didn't work too well. So I was in a mad scramble with about a month left to finish the project and no way to charge a phone. That was not too pretty. So that's where I found these boards, and they gave me 5 volts reliably with 2 AA's. That's great. I plugged my phone in using just one of these boards, and it wasn't charging. A little research later shows Apple, being Apple, requires you to, tries to keep their chargers proprietary. They require, well, with a USB connector you have 4 pins. You've got a positive 5 volts of ground and 2 data lines. Most USB phones require just the positive 5 volts in the ground to be connected, and that'll charge a phone. Apple decides to be ingenious and require about 3.3 volts on the 2 data lines in order to charge their phones. So I had to make some modifications to the board to give us the 3.3 volts on the 2 data lines. After we got that, we got working electronics, and it worked flawlessly. And I thought our hard times were over, and we were going to work on our enclosure. Once we had the electronics, we knew what we were encasing, so we needed to come up with the enclosure. The school has some wonderful resources, such as a 3D printer, and that's what we decided to use. Get a nice custom, as compact as we can case. But we had some difficulties with the printer. Our first design, our first problem, I should say, was with the software. We first started using Blender. That's what I was most comfortable with at the time. That's what I've had several years of experience modeling with, was Blender. Turns out exporting the file type for the 3D printer causes all sorts of problems. This was supposed to look like this. That was very concerning when it didn't print what it looked like it was supposed to print. Someone then said, oh, that would take 5 minutes to do in my software. It was Inventor. And then this is what we got. Again, not quite what we're looking for with the support structure, missing rails, not what we wanted. So someone else suggested yet another piece of software. This one was free, that anyone can use, and it gave us exactly what we were looking for. So once we figured out how we can make the models, we were able to move on to making our enclosure. And that's where we ran into issues with the printer itself. The printer would stop feeding filament into the extruder head after about 5 minutes. And I don't know what the issue is. But in order to remedy that, we had to sit by the printer for the entire 7 hours it took to print, shoving the plastic up the tube. So that made for a very interesting print session. We started with a nice box, just trying to make sure everything fits, and then we just kept revising our prints until we get cleaner prints that are more compact, and eventually we ended up with our final project with a matching lid, and everything fits in nicely. It's just about as compact as you can get, and it worked on the first go, which was very astonishing considering the roadblocks we had. And just to prove to you that it does work, let me grab my phone and plug it in, and it's charging on one set of AA's. And the best part about this is the AA's, it'll take regular alkaline batteries, it'll take your rechargeable nickel metal hydride NiCad, as well as lithiums. It'll take it all, and it won't fuss at all. We should get about 1.5 to 2 charges approximately from the math of full battery charges of the phone off of one set of alkaline AA batteries. So that's pretty impressive. Yeah, you're up next.
doing cost as well. Most of them have already talked about it. We're asking for about $12 for the product, but for the case, battery holder, and electronics, this is the full cost chart. We have $1 for the case, battery holder $2, and electronics $2 as well, and $7 for the profit. And then we also converted that into a percentage chart, which gave us a 15% profit out of everything.
So future goals and hopes and maybe dreams, they probably won't come true, is first is a more reliable 3D printer, so we don't have to worry about all these mess ups and all that sort of stuff. Next would be nice to work on the lid a little bit more, make it more secure and make it easier to print.
Going to mass scale, we would also probably look at molding injection.
Yeah.
Just because it would, on a mass scale, it would be much more efficient, effective, and it would probably get our profit up and our cost of to the consumer down, so.
I think that's it.